Welcome, Hornets, and thank you for showing up today. We are looking at part two of assignment number two, which is found on page 299. We are looking at numbers 21 through 27 odds only, then number 37, 41, and then 45 through 57 odds. We'll see how much we can get done in part two, but I may have to have part three as well. So let's go ahead and begin. So in number 21, we are being asked to use the summation formulas to write the expression without the summation notation. Use the results to find our sums with n equals 10, 100, 1,000, and 10,000. So the first thing that we're going to want to do when we look at this is we're going to want to change this to be 1 over n squared. And we're doing our summation as I goes from 1 to 10 for 2i plus 1. Now, we know that 2i plus 1 has a formula. So I'm just going to go ahead and I'm going to just kind of do my simplification. I'm going to 2 over n squared. And I'm multiplying it by my formula for I, if you recall from part 1, which was n plus 1 divided by 2. And then we have plus 1 over n squared, and we're multiplying it by n. And in this, we're going to be looking at, so let's just go ahead and simplify this as far as we possibly can. Let's see, this is going to give me 2n squared plus 2n divided by 2n squared, and that's going to give me 1 plus 1 over n. So that's what this is going to equal to. And if I have n equaling 10, then I'm looking at having 11 tenths. Notice how I put that right in there. Then let's go ahead and take a look at what happens if I have 100. N equaling 100 is 1 plus 100th, which I'm going to write as 1.01. If n equals 1,000, I'm looking at 1 plus 1,000th, and that's 1.001. And then the last one was 10,000. This is 1 plus 1/10,000th. And here are the four answers that we are looking for in number 21. Now 23 is going to follow the same basic pattern, so I'm going to let you go ahead and try number 23 as we now go to number 25. Now in number 25, we are being asked to use rectangles for the equation f of x equals 2x plus 5 over the interval 0 to 2, and we want 4 rectangles. So the first step is to find delta x. Delta x is 2 minus 0 divided by 4, and this gives me 1/2. So the x values that I'm working with are going to be 1/2, 3/2, 2, and 0. So notice we're going up by 1/2 each all the way from 0 to 2, and we're trying to work with rectangles. So if I'm trying to work with my rectangles, that means that I'm going to take my length of 1/2 times my first height, and that first height, let's just get a nice picture of what's happening. And if I'm working with my rectangles, they want us to use the right endpoint and the left endpoint. 0, 1/2, up. There's a 1 missing. x equals 1, 3 halves, and 2. So if I use the left Riemann sum, I'm using my height, which is going to be 5 times 1/2, plus the next height is going to be 6 times 1/2, plus the next height, 7 times 1/2, and then our last one is going to be, 8 times 1/2. And that's going to give me 5 plus 6 plus 7 plus 8, 15. So I'm looking at 26 times 1/2. And I end up with 13 as my left Riemann sum. Let's now go for our right Riemann sum. This is now working with this height. Notice it's going to be an over approximation. So I'm now plugging in 1/2, and that's going to give me the 6 length 1/2, plus 7 length 1/2, plus 8 length 1/2, and then I'm going to have a 9 length 1/2. And this is giving me, 6 plus 7 is 13, 21, 30 times 1/2 for a total of 15. So my left Riemann sum was 13, and my right Riemann sum was 15 using 4 rectangles. The last one is number 27, which I'm going to leave that for you to try. This then brings us to number, I believe that's 37. And number 37 is now asking us to do the full limit process. So 37 is asking us to find the limit as n is approaching infinity for the summation of 24i over n squared as I goes from 1 to n. So you'll notice the first thing I'm going to do is say that this is the limit as n approaches infinity, and I'm going to make sure that I take out the 24 and the n squared, leaving me with only the I term. Now we know that I, the summation, as I goes from 1 to n, is n times n plus 1 divided by 2. So I'm going to do a direct substitution. 24 over n squared times n squared over 2. Now we only work with the highest power because the other piece, and I'm going to go ahead and I'm going to do it once just to remind everybody, is going to have a power of n greater in the denominator, and therefore it's going to end up going to 0. Notice that this piece right here has 12 plus the limit as n approaches infinity for 12 over n. And this goes to 0. So my answer is 12. That is what I'm trying to find in number 37. Okay? Once again, this is all we're trying to do. I only asked you to do one of those. And then I asked you to jump to number 41. So let's take a look at 41, please. 41, a little bit more difficult, but not by much. We are asked to take the summation, and this is once again the limit as n is approaching infinity. And we have I starting at 1 and going to n. And I have 1 plus I over n times 2 over n. Now, I'm going to go ahead and I'm going to work with this one piece at a time. After all, I can look at this as the limit as n approaches infinity for the summation as I over n times 2 over n, I going from 1 to n, plus the limit as n approaches infinity for the summation of 2 over n times 1, and I goes from 1 to n. Now, as I do this, I have the limit as n is approaching infinity for 2 over n squared times the summation of I. But we're only going to work with the n squared over n as our substitution. 2 over n squared over 2, limit as n is approaching infinity. This is 2 over n of 1. Limit as n is approaching infinity for 2 over n times, and now I just have n. I'm looking at 1 plus, and I end up with a 2 here. So I have 1 plus 2, and my answer for number 41 turns out to be 3. My answer is 3. And I hope that helped. Now there's only one more part left, and that's numbers 45 through 57. And this is finding the area by the limit process, and that was what we have just worked with. So let's take a look at number 45, just so that you get an example. And then I'm going to let you finish the rest of those all the way up to 57. So in 45, we're looking at y equals negative 4x plus 5, and we have our 0 to 1. So we're going to find our delta x. Delta x is 1 over n. So I'm now going to set this up as the limit as n approaches infinity for the summation I starting from 1 to n. 1 over n is going to go in front just so that I don't get confused. And I have negative 4. And inside I'm putting 0 plus I over n plus 5. This is now what we're going to work with. Now you'll notice the 0 is going to go away, so I'm just looking at the limit as n approaches infinity. And I have 1, and I'm going to bring out the negative 4 over n becomes n squared. I equals 1 over n for I. So I've already factored out that piece. I then have plus the limit as n is approaching infinity. I'm looking at 5 over n times the summation of 1. I goes from 1 to n. This then gives me negative 4 over n squared multiplied by n squared over 2 plus 5 over n times n. I get negative 2 plus 5, and my answer is 3. So for number 45, I end up getting 3 again. All righty. This brings us to number 47. One more, and then I'm going to leave the rest to you. Number 47 works with y equals x squared plus 2 over the interval 0 to 1. We're using the limit process to find the area. So step 1 is to find your delta x. Delta x is b minus a divided by n. That's going to give me 1 over n. I know that x is going to be 0 plus 1 over n times I, and that becomes my x sub I. Here we go. Putting it all together, we're looking at the limit as n is approaching infinity for 1 over n summation of x squared plus 2. We're going to have to put it in and put it together. So the limit as n approaches infinity for 1 over n, I'm now putting in my x. This is going to give me I over n, and it's squared, I equaling 1 to n, and then I have plus the limit as n approaches infinity for 2 over n, summation of 1, I equaling 1 to n. This is now what I want to work with. This is the I squared. This is going to give me the limit as n approaches infinity for 1 over n cubed times the summation of I squared plus the limit as n approaches infinity. And we can go ahead and talk about this as 2 over n times n. There went my lights again. We love this district and this school. They have such wonderful technology, such that you can't even see me. I hate this, but here we go. We have to finish. So we're going to finish our process. The limit as n approaches infinity for 1 over n cubed. Now we're only working with our highest power. And you'll recall I squared was n times n minus n plus 1 times 2n plus 1 divided by 4. And that's going to give me my, let's write this down, n plus 1, 2n plus 1. And this was divided by 6. There we go. And this is going to give me n cubed over 3 plus 2. Simplifying this, 1/3 plus 2, and my answer is going to be 7/3. And that is my answer for number 37. Alrighty. If you have any questions, please feel free to come in and ask. I'm going to leave the remainder of the problems for you to work on and practice and try on your own. Thank you very much. Take care, be safe, and have an excellent afternoon. Good night, and be well.